Miss Parent here again with you. We're going to do another vertical circle problem, but this one is going to combine energy and circles. And this comes back to our good old friend Steve Trotter.
Will say this to me. Did you test it, Steve Trotter? I'll say, what do you mean, how did I test it? Do you want me to jump off with a couple blow-up dolls and build up the cement and test it that way? Will that make you happy?
No, Steve, but using physics would make me happy. And so this is how Steve Trotter technically could have tested his idea and made it safe so that he and his, not one, not two, not three, but 5 friends could have successfully made the pendulum swing. And Steve Trotter could have done it this way. What is the minimum tension required so that the pendulum swing safely makes it all the way around? And in order to do this, the first thing Steve Trotter probably should have done is taken a look at the forces acting on the pendulum at the bottom of the swing. And what I know is that gravity is going to act down out of the circle, and tension is going to act upward in towards the center of the circle. Okay? And I know that at this point, my net force equation, F net, equals MAC, because a pendulum motion mimics the motion of a circle. So I'm moving with a circular eccentrical acceleration. And I know that my net F net is my helping force or tension, because it points inward, minus gravity, which points outward. So this is going to be tension minus Fg equals mv squared over r. Okay. Now, something that I know that I will need is I'm going to need the speed of the guys here at the bottom. Well, I don't know that from what I'm given. And so I can find that through, you guessed it, energy. And the nice thing about this is it works out very simply and very beautifully. And so I'm going to say that at the level, the lowest level here that the pendulum reaches, I'm going to call that my 0 level in terms of potential energy due to gravity. And so when the guys are going to jump off the bridge, the guys in the one woman, excuse me, up here at this point, they jump. We're going to assume that they have 0 initial velocity, more like they drop off the side. And so they only have a potential energy here. And so that would be UG. And the height that they are at is this H here above the 0 position. And when they reach the lowest point of the swing, all of their energy has turned from potential into kinetic energy. So it's all KE down here at the bottom. Okay. I also know that the rope has a length of R, if I want to say, or I could say D, whichever term you prefer. Okay. Now, conservation of energy says that energy can neither be created nor destroyed. And so I end up with this statement for Steve Trotter. I have UG is equal to KE, which tells me that MGH is equal to 1/2 mv squared. And I want to solve for this v. That way I know how fast they're traveling at the bottom of the pendulum. And so I'm going to multiply everything by 2 to get rid of the 1/2. So I get 2 mgh equals mv squared, and then I'm going to divide by m, which causes my m to drop out of the problem, and I get v squared is equal to 2gh, which means that when I take the square root, I get v is equal to radical 2gh. Cool! Now what can I do with that? Well, that's how fast they're going down here at the bottom. And so this v right here, I'm going to take that and I'm going to plug it in to this v over there. Okay. Remember, I'm trying to solve for tension, so I want to keep this T. So I'm going to have tension minus Fg is equal to m. And now I want v squared, so I'm actually going to write just 2gh. over r. Because v is radical 2gh, and then if I square it, that just gets rid of the square root. What do I know about h and r? What do I know about these guys? Well, if I take a look at this picture that I drew here, r is the length of the pendulum, and h is the length from the bridge to the bottom of the swing, and they are one and the same. So h is equal to r. And if h is equal to r, that means that this divides out of this term. And I'm left with tension minus Fg equals 2mg. I just rearranged this. 2 times m times g. And then I have to add Fg to the other side. So then I get tension is equal to 2mg plus mg. Well, what's 2mg plus 1mg? That would tell me that the minimum tension needs to be 3mg. This is a nice simple answer that Steve Trotter could have used. This statement here tells me that that wire needed to have supported at least 3 times the weight of all the passengers. And if that was the case, they would have been successful in their swing, and not this.
They're catapulted down towards the bay, falling about 7 stories. Just moments earlier,
That's a beautiful picture of inertia.
That very possibility.
So Steve Trotter didn't have to jump off the bridge with blow-up dolls full of cement. He could have used some physics to figure it out. And if you ever run into him, you can tell him all he needed to know was 3mg. But this is a nice example of a problem that combines circles and energy, which you may very well run into on your AP exam.